we're going to talk about Pascal's triangle. Before we start with this lovely triangle, over here to the side we're going to make a little note, something that's kind of important. So we're going to talk about pattern for when we have I to a power, because there is a pattern you can follow. So if you have I to the first power, that's just going to be I. We know I squared is -1. If you have I cubed, that's going to be -I, because you can take I squared, which is -1, times I to the first, which is I, which would give you -I. You have I to the fourth, which would be +1. So I squared is -1 times I squared, which is -1. -1 times -1 gives you +1. So then we can repeat. So if we have I to the fifth, that's going to be I to the sixth is going to be -1. I to the seventh is going to be I to the eighth is going to be 1. And then the pattern continues. You can go I to the ninth, you can go I to the 10th, I to the 11th, I to the 12th power, I to the 13th, I to the 14th, I to the 15th, I to the 16th, and it just keeps going. So there is a pattern that might be helpful if you need to follow it. Another thing, when we talk about signs, if you have a negative number to an even power, so let's say this was -2 squared. Well, if you square -2, you're going to end up with a +4. So if you have a negative number to an even power, it's going to be positive. If you have a negative number to an odd power, so if we have -2 cubed, so to the third power, that would be -8. So when you have a negative number to an odd power, your answer is going to come out negative. So those are just a couple notes. So let's start talking about our triangle. So when we talk about our triangle, we're going to have coefficients. And our coefficients for Pascal's triangle, we start out with 1. And then on the second row, you're going to have 1 and 1. So then you work down from there. You're going to have 1, and then you take 1 plus 1 to give you 2. So you're adding these two. And you have 1 on the sides. So we're always going to have 1 on the side all the way down. So the fourth one. So we have 1 on the side. Then we take 1 plus 2 to give you 3. 2 plus 1 to give you 3. And we have 1 on the side. Again, we start out with 1. You take 1 plus 3, which is 4. 3 plus 3, which gives you 6. 3 plus 1, which gives you 4. And we end up with 1. Next row, you have 1 on the side. 1 plus 4 gives you 5. 4 plus 6 gives you 10. 6 plus 4 gives you 10. 4 plus 1 gives you 5. And we end up with 1. Alright, so let's kind of start filling this out a little bit. So if we have a plus b to the 0 power, we're going to have 1. Okay, so then if we go to a plus b to the first power, that's just saying a plus b. So you're going to end up with 1, and we're going to use different colors. So we have 1a, and let's go with pink, plus we have 1b. Then if we have a plus b squared, if you were to FOIL that out, so if you took a plus b times a plus b, you'd end up with 1a squared. So we have plus 2ab, so 2ab plus 1b squared. So if you see, so far we're following our pattern. We started out with 1, then we went 1a plus 1b, then we went 1a squared plus 2ab plus 1b squared. So let's hope our next one is 1, 3, 3, 1. So if you were to cube this, if you have a plus b cubed, we'd end up with 1a cubed plus 3a squared b plus, oops, wrong color, 3ab squared plus, then we have 1b cubed. So far so good, we followed that one. So now if we do the next row, let's hope we have 1, 4, 6, 4, 1. So if you take a plus b to the fourth, you're going to end up with 1a to the fourth, and we have plus, I'm just going to put our plus signs in there. Then we have 4a cubed b plus 6a squared b squared plus 4ab cubed plus 1b to the fourth. Alright, so our next row is a plus b to the fifth. So let's hope it follows this pattern. 1, 5, 10, 10, 5, 1. So we start out with 1a to the fifth plus, then we have 5a to the fourth b then we have plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the fourth plus 1 b to the fifth. Alright, so let's keep going. So if we take a plus b to the sixth power, we're going to end up with 1 a to the sixth. And let's just go ahead and put our plus signs throughout. So then we have plus 6 a to the fifth b plus 15 a to the fourth b squared. Then we have plus 20 a to the third b to the third plus 15 a squared b to the fourth plus 6 a times b to the fifth plus 1 b to the sixth. I hope you are seeing a pattern here. Let's see if we can look at our pattern before we keep going. So if we look at our a's, so all of your a terms in here. So if we look at, let's just pick this row. So if we pick a to the fourth, if we look at our a's, we're always starting out with a to whatever power your row is. So if we look at the fourth row, it starts out with a to the fourth. So it's a to whatever row you're looking at, and as you keep going, you're decreasing the exponent until you end up with no a's at all. So on this one, we started out with a to the fourth, and we kept going down one. So we went to a to the third, a squared, to no a at all. I need to move that over for you. So now if we look at our b terms, So if you look at the B's, we start out with just the opposite. We start out with no B's at all, and as we keep going over, we end up with B to whatever row you're looking at. So this time you're going to increase the exponent. So for example, if we look at this row again, we start out with no B at all. Then we increase. Well, so if we start out with no B, then we go to 1B. Then we go to B squared. Then you go to B cubed. Then you go to B to the fourth, which is what row you're looking at. So let's finish this out using that pattern. Alright, so we start out with 1, a to the 7th. So we start out with a to whatever row we're looking at. So a to the 7th plus 7. We know our a is going to decrease, so we're going from 7 to 6, and our b is going to pop up for the first time. So 7, a to the 6th, b, plus 21, we're going down another one, so a to the 5th, and with the b's we're going up one more, so b squared, plus 35, and the a's we're going down, so a to the 4th, and the b's we're going up, so b cubed, plus 35, and the a's were going down, so a cubed, b's were going up to b to the 4th, plus 21, a were going down, so a squared, the b's were going up to b to the 5th, plus 7, a's were going down, so we're left with a, the b's were going up to b to the 6th, plus 1, so now we're left with no a's, and we're going up to b to whatever row we were looking at, which was the 7th. Alright, so one more. So next we have 1, a to whatever row we're looking at, so to the 8th. Let's put our plus signs in there. So then we have plus 8. So we're going down one, so we start out with a to the 8th, so now we're going a to the 7th. And here comes our first b, plus 28. So we're going down one with the a to a to the 6th, and we're going up one with the b to b squared. Then we have plus 56, and we're going down one, so a to the 5th. And the b's we're going up one to b cubed. Then we're going plus 70. A's we're going down one to a to the 4th. B's we're going up one to b to the 4th. Plus 56. A's we're going down, so a to the 3rd. The b's we're going up, so b to the 5th. Plus 28. A you're going down, so a squared. B you're going up, so b to the 6th. Plus 8. A you're going down to a. B you're going up to b to the 7th. Plus 1. And we're left with no a's, but we're left with b to the 8th. Alright, so there's that table for you. So now let's do a couple examples where we actually use this table. So our first example is 2c plus 3 to the 5th. So if we look at this, we are going to replace every a with 2c, and we're going to replace every b with 3. So we're trying to make it look like something in our triangle up there. So what that's saying is we're going to take our 2c, we know it's to the 5th power, so we have a plus b to the 5th. So we're going to plug in 2c for the a's, and we're going to plug in our 3 for the b's. So if we look at a plus b to the 5th, if you look at your triangle, we have 1a to the 5th plus 5a to the 4th b plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the 4th plus 1 b to the 5th. So if we go through, we have, let's use the same color. So we have an A here, an A here, an A. So I went through and circled all the A's that we're going to replace, and now I'm going to go through and circle all the B's that we're going to replace. So now let's actually do that. So that's really 1 times A, so we're going to replace A with 2C. So you have 2C to the 5th plus 5 times A, which is really 2C to the 4th, times B, which we're replacing with 3, plus 10 times A, which is 2C to the 3rd, times your B, which is 3 squared. Plus 10 times our A, so A squared, so 2C squared, and we have B to the 3rd, and our B is 3, plus 5 times A B to the 4th. Well, our A is 2C, and our B is 3, so 3 to the 4th, plus 1 times our B, which is 3, to the 5th. So now this is where this comes into play. So we replaced the A's and the B's, so we did that already. So now we're going to take the numbers to the powers, so meaning we're going to take the number, so 2 to the power of 5, and put the exponents on the variables. So our variable is c, so we're just going to put the exponent on c, so it's going to become c to the 5th. And then we're going to multiply the coefficients out front when we get there. So let's go ahead and do that step. So we have 2c plus 3 to the 5th. So that was our problem. That's going to equal, so if we take 2 to the 5th power, that's going to give you 32. And then put the exponents on the variable. So this variable, we're just going to stick the exponent on it. So it's going to be c to the 5th. Plus, so we have 5 times 2 to the 4th. It's going to give you 16. And stick the exponent on the variable, so c to the 4th. Times 3. Plus, we have 10 times, so now we have 2 cubed, which is 8. Stick the exponent on the variable, so it's going to become c cubed, times 3 squared, which is 9. So we're just working piece by piece. So now we're looking at this piece. So now we have plus 10 times, so now we have 2 squared, which is 4. Stick the exponent on the variable, so c squared, times 3 cubed, which is 27. Now we have plus So we're going to take 5 times, we don't have an exponent here, so that's just 2c, times 3 to the 4th, which is 81, plus 3 to the 5th, which is 243. So now let's actually do that. So we have 2c plus 3 to the 5th. That's going to equal. So this is already simplified, so we have 32 c to the 5th plus, we have 5 times 16 times 3 is going to give you 240, and we still have c to the 4th. So now we're looking at this piece. So now if we take 10 times 8 times 9, you're going to get 720 c to the 3rd. Plus, if you take 10 times 4 times 27, that's going to give you 1080 c squared. So now we go on to this piece. If you have 5 times 2 times 81, that's going to give you 810 c plus 243. Alright, let's do another one. So this one, you have x minus 5y to the 4th. So if we look at a plus b to the 4th, that comes out to be 1a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus 1b to the 4th. Alright, so in this case, our a's, we're going to replace those with x. So we're going to put x's where all of our a's are. And our b's, we are going to replace those with negative 5y. So right there, there, right there. All of our b's. So if we were to do that, we'd start out with this piece first. So 1 times a to the 4th. So you take 1 times a to the 4th. Well, our a is x, so it'd be x to the 4th. Plus 4 times a cubed. Well, our a is x, so x cubed, times our b, which is negative 5y. Plus 6 times a squared b squared, so a is x squared, and b squared, our b is negative 5y squared. So now we have plus 4 times a, which is x, times b cubed, so b, which is negative 5y cubed, plus 1 times b, which is negative 5y to the 4th power. Alright, so let's simplify it a little bit. So we have 1 times, so we just have x to the 4th, plus, so we can take, we know if we're going to multiply negative, that's going to change this to a minus, not a plus. So minus, and we have 4 times x cubed times 5y. Then we have plus, because we said if we have a negative number to an even power, it's going to be positive. So that's going to be positive. So 6 times x squared times, if you square 5, you get 25. And then y squared. We have a negative number to the odd power, so it's going to be negative 4 times x times, if you take 5 and cube it, it's going to be 125 y cubed. We have a negative number to an even power, so that's going to be positive. If you take 5 to the 4th, we get 625 y to the 4th. Now we can simplify it. So we have our original problem, which was x minus 5y to the 4th. That's going to equal, well, 1 times x to the 4th is x to the 4th minus 4 times 5, which is 20, x cubed y, plus 6 times 25 is 150, and we still have x squared, y squared. And then we have 4 times 125, which will give you 500, and this is still a minus. And then we have x, y to the 3rd, plus 1 times 625 y to the 4th is just 625 y to the 4th. Alright, let's do one more. So we have 3 plus I to the 4th. So if we look at a plus b to the 4th, that's the same as the one before. So we have 1a to the 4th plus 4a cubed b plus 6a squared b squared plus 4a b to the cubed plus 1b to the 4th. Alright, so our a's are going to be 3. And our b's we're going to replace with I. So all the a's are going to become 3's, and all the b's are going to become i's. So let's go ahead and do that. So we have 1 times a to the 4th. Well, our a is 3, so it's 3 to the 4th. And we have plus 4 times a cubed, so 3 cubed, times b, which is I, plus 6 times a squared, so 3 squared, times b squared, which is I squared, plus 4 times a, so times 3, times b cubed, so I cubed, plus 1 times b to the 4th, so I to the 4th. Alright, so this now becomes 1 times 3 to the 4th, which is 81, plus 4 times 3 cubed, which is 27, times I, plus 6 times 3 squared is 9, and I squared, plus 4 times 3 times I cubed, plus 1 times I to the 4th. Alright, so we have 1 times 81 is 81, plus 4 times 27 is 108 times I, so 108I. Alright, so we can take 6 times 9 is going to be 54 times I squared. Well, I squared is negative 1. So 54 times negative 1 plus 4 times 3 is 12 times, if you look back, the very first thing we talked about, I cubed is negative I. So I cubed became negative I, plus 1 times I to the 4th. Well, if we look at I to the 4th, I to the 4th is just 1. And 1 times 1 is just going to be 1. So if we simplify that, we have 81. We have plus 108i. 54 times negative 1 is going to be negative 54. 12 times negative I becomes negative 12i. 1 times 1 is plus 1. So if we combine our like terms, we have our original problem. 3 plus I to the 4th is going to equal. So if we combine like terms, we have 81 minus 54 plus 1. So 81 minus 54 plus 1, that's going to become 28. And then if you take 108i minus 12i, you're going to get 96i.